All right, young people and those on the wide web. I'm going to talk a little bit about end behavior using limit notation. Prior to this, you thought end behavior was just two arrows. And yes, it's true, but we have to make this more mathematical in nature to make it more fun. So let's be fun with it, okay? So let's consider this first example here. X plus 2 times x minus 1. The zeros in factored form, it's like, thank you very much, Mr. Roboto. That was a great gift. Negative 2 and positive 1. So I could sketch my graph, putting zeros there and there. Which direction does this function open? Opens up. So some of the childs out there are thinking, oh, end behavior, that's good enough. Well, slow down your pony there, child. We're going to put this into what we call limit notation for end behavior. Before we get there, though, let's talk leading term. What would the leading term be? X squared. Thank you much. So it's got a positive coefficient with an even power, of course, which would be up and up. And the y-intercept would be 0, comma what? Negative 2. Very good. We plug in a 0, we get out a negative 2. Now, in the past, you might have felt comfortable with doing this and behavior up and up. I'm going to talk about both of these behaviors. Let's talk about this one first. What is x doing in this case, right here? X is going to what? X is decreasing to negative infinity. So the limit of the function f of x as x goes to negative infinity equals what? Where does the function go? Up, right? And what is up without bounds? Positive infinity. So this right here means as we travel to the left, and this right here means the function increases without bound. Without bound. All right, so let's see. That's our left end behavior. Where's my? So the right end behavior. So as x goes to the right, which would be positive infinity, what happens to f of x? Talia? Goes up to infinity. So this right here is as we travel to the right, this right here tells us the function increases without bound again. So if we have an even powered polynomial, what do we know about what the function is going to do? Right, they'll be the same, right? If we have an odd powered polynomial, we know those two will be different. And then these two right here, these will always be different, right? Because one's as we travel to the left, one is as we travel to the right. Cool? So that's limit notation for end behavior.